So some problem solving using Heron's rule. So we've got two rowers, that's their names, they set out from the same point and they go in sort of different directions for certain distances. So first things first, let's draw a diagram. Okay, so they both start from the same point and one of them goes north 70 degrees east, right? So if we picture our compass, we've got north, south, east, west. And what this is saying is they go, if we start at the north and then go 70 degrees to the east, it's going to be almost to the east line, right? And this would be 70 degrees. Okay, so in other words, Harriet travels about this distance, or this direction, sorry. And she does so for 2,000 meters. All right, we can draw another line up here and say that this is 70 degrees. All right, we also know that this would be 20 degrees down here, but for now I'm just going to leave it at that and we'll see what other information we need. Kate rows south 15 degrees west. So we start at south and we go 15 degrees to the west. Okay, so she's sort of down this way, where this is 15 degrees. And she does so for 1,800 meters. Calculate the distance between the two rowers corrected 2 decimal places. So if we do a quick bit of tidying here, I'm going to get rid of this line and this line. And I'm going to say that this was 20 degrees in here. Okay, because it was the 70 plus whatever we needed to get to the east, which was 90. Okay, here we had 15 degrees, and then we know that this is 90 degrees in here. Okay, that's this section here of our compass. So it's 90 degrees between east and south. And then I'm going to draw a line that connects the two together, and this is what we're solving for. So we could just call this, we'll call this A, and we'll make sure that we use the correct formula to solve for A. So to find this angle that's made up of the 90, the 20, and the 15, we just add them together, right? So 90 plus 20 is 110, plus 15 is 125. So I'm going to relabel this 125. And this will be A, capital A. All right, we can call this lowercase b and lowercase c. So we've been given two side lengths and the angle between them, and we're solving for another side length. So let's look at our formulas here, our cosine rule. We've got angle A in our question, and we're solving for side length A. Okay, so we're going to use this formula. Again, I'll do my best to remember it. So we know that A squared is equal to B squared plus C squared minus 2BC cos of A. All right, let's double check that. A squared is equal to, yep. And again, we want to solve for A, so we're going to take the square root of both sides, okay, to get rid of the squared. And that's going to leave us with the square root of B squared plus C squared minus 2BC cos of A. All right, you could Like I said earlier, you could do the square root after you've solved all of this. You'll still get the right answer, okay? As long as you do it at some point. I just like to rearrange for it now so I know that I'm just solving from the start. So next step is to substitute in. So B is 1,800 squared plus 2,000 squared minus 2 times 1,800 times 2,000 times the cosine of A, which is 125. Okay, and then again, we can really carefully put this into our calculator. Let's simplify a couple of things just one at a time. So 1,800 squared is, okay, they're big numbers, so let's just put the whole thing in one go, being very careful to use brackets where we need to make sure that we're doing our order of operations correctly. So the square root of 1,800 squared plus 2,000 squared minus 2 times 1,800 times 2,000 times the cosine of 125 equals 3371.91 meters. Okay, our units were meters for our 2,000 and our 1,800. So our answer is in meters. So A is equal to 3371.91 meters. And we'll do a quick sanity check. So if this is 2,000 meters and this is 1,800, then it would make sense that this would be 3,371. Like they're in the same ballpark, those answers. Okay, those values. And so we've solved the distance between to 2 decimal places.